Hello everyone. Thank you so much for joining us today to get your dose of application security. My name is Paul. I'm a security architect for Trend Micro. I also I am an ethical hacker. I am part of the OWASP Ottawa organizing committee. I am very passionate about teaching people about application security. I also contribute to an open source project. It's called the Secure Coding Dojo. Check it out on GitHub. And actually the training platform that Garth has mentioned, where you guys can go and practice injection, is powered by the Secure Coding Dojo. Okay, so injection. So I was not surprised when OWASP has released the new OWASP Top 10 for 2017. That injection was still #1. It is, if you were thinking of application vulnerabilities as songs in a music chart, injection is at the top of the charts. It's been there for since 2010, so quite a bit. It's a big hit. And that was the OWASP Top 10. This is another top, the minor Top 25, also known as the Science Top 25. At the top of this list, you have two types of injection: SQL injection and command injection, OS command injection. And these are the two types of injection that we're going to be talking primarily today. And injection is making the headlines. So every time you hear about a data breach, this company, all these social security numbers got exfiltrated, their credit cards got exfiltrated. A lot of times it's done with the SQL injection or command injection, but it is so one of the largest data breaches, the Heartland Payment Systems breach, was done with the SQL injection. The Yahoo server were owned with Shellshock, which was, if you heard about it, Shellshock, a vulnerability in the Bash Unix command line. That was command injection vulnerability. Recently, I just heard of this Trustico certificate authority, which was in the news for emailing private keys. And then after that, somebody found that their website was pretty much allowing anyone to execute commands, and that was again in the news. So you keep hearing about it. And as I was mentioning earlier, there are many types of injection. So we have the SQL injection, which is the ability to insert arbitrary SQL commands in database query. Then you have the NoSQL injection for the NoSQL type of databases. Then the OS command injection, which is the ability to insert commands in operating system shell calls. Then we have LDAP injection. That is the ability to alter the logic of an LDAP query. XPath injection, alter the logic of an XPath search in an XML document. And we have more: MX, ORM, OGML, I don't even know what that is. And then there's some related type of attacks. I could say that the mass assignment presentation we just had earlier could be seen as an argument or object property type of injection. People talk about JSON injection, XML injection. Well, if we're going to talk about XML injection, how about HTML injection? What's HTML injection? Cross-site scripting. That would be an HTML injection. So I saw an article from someone saying, let's remove all the OWASP Top 10. There's only one type of vulnerability, and that's injection. But just so we don't oversimplify things, we're going to say that injection is when you can change a command pass to an interpreter. Okay, so a command interpreter, that is injection. All right, so just to make sure you get, I wanted, because I know it's going to be after the pizza, you're going to be sleepy. I was thinking to keep it fun, have games. So we're going to play what type of injection is it? And if you can tell me what type of injection is this? SQL injection, let's see if you're right. You were correct, it is SQL injection. Let's see the next one. How about this one? That's right, this is OS command injection. You see the software is trying to execute a backup, and maybe it's taking the name of the backup file from the user, and the user will put in a whole other command in there, okay? And so it influenced the shell execution. How about this one? So I'm hearing NoSQL. Let's see if you're right. Jackpot. NoSQL injection. So NoSQL injection is, if you haven't seen it before, pretty much JavaScript. Okay, so it's JavaScript executed in MongoDB. The MongoDB allows for the where keyword. And what's happening here is somebody concatenated this JavaScript. The interesting part about NoSQL injection, it can cause DOS because you put in an endless loop in your command. So it's a combination between command injection and SQL injection. So to sum it all up, injection is the ability to insert arbitrary commands into a string passed to a command processor. And the type of injection takes the name of the affected command processor, right? So SQL, OS command, LDAP, etc. And SQL and OS command injection are the most widely exploited. So what causes injection? Concatenation. Okay, so what's happening? You have a command, you concatenate it with user input, the user replaces the input with another command, resulting in injection. So concatenation causes injection. You can repeat with me if you want. Concatenation causes injection, right? Also, string replacement, which is not replacing your strings on the guitar, but it's a type of concatenation, right, pretty much. So let's see if you guys can spot some injection. Can you see the screen? So there's the top one has an array of strings. You got bin sh -c, and it has string format ping -c 4%s update server. The one at the bottom has pretty much the same thing, but at the bottom it says ping -c 4 plus update server. So which one is injection, the top or the bottom?
Can you do it? You can do it both, can't you?
Okay, so who had both was right. It was both, yes. So the bottom does concatenation, but the top does string replacement. How about this one? So the top is just a string of, an array of strings. At the bottom is again an array of strings, but you have plus update server. So which one, top or bottom?
Bottom.
It is bottom. How about this one? All right. So I heard top. So the top again is that string format, and the bottom, you have these question marks. When you see those question marks, it's a good thing. So we'll see more why. The answer was top. Excellent. So to sum it all up, the recipe for injection, you have hazardous input concatenated into a query or command string. So command plus input is equal injection, also replacement, and format cause injection. Right? So if you have the string replace. Searching for injection, so there's supposed to be a needle in a haystack. All right, so quotes, okay? Quotes are essential for finding injection. You have all kinds of varieties of quotes. You have single quote, double quote, back quote. And you pretty much go and interacting with a website or a command line application, doesn't matter. You go and you put a single quote, and what happens? Look at the top command. You have an unenclosed quote in the command. What's that going to cause? And what's that? That's an error, right? So it's going to be an error. How about the bottom? You have a single quote, then you have a double quote, then a single quote. Again, that's going to cause an invalid command. It's going to cause an error. So looking for errors. So when quotes cause errors, then we may have injection. Okay? And usually they're the type of errors that you know the application wasn't expecting that kind of, it did not handle them. Right? They're unhandled exceptions. So you'll have a big stack or 500 errors from the server. So they're unexpected errors. But there's also a situation when you don't get errors, and that's blind injection. Okay, so that's sometimes you just get an internal error has occurred and you don't know why. Or you just don't get any error whatsoever. You just notice the application is behaving a little bit differently. So what you could do when if you're really searching to find injection, or if you're a pen tester or security researcher, you first try to see, well, my quote caused an error. Was that error caused by my quote or by something else? So one thing you could do is you add two quotes of the same kind. Okay? So if one quote caused an error, adding another quote will solve the error because you didn't leave the quote unenclosed, so the interpreter will be okay with it. So for example, in this command line excerpt, you have a single quote causing an unexpected EOF while looking for matching other quote. And then the bottom is just fine. There's no error, right? So you have two quotes is fine, one quote is bad. Also, tautology. So what tautology means, you influence the logic of a query to be always true or always false. Okay, and then after you do that, you compare the outcome, and that's application security scanning tools. They do that a lot of times. So, for example, if you have this SQL statement, select star from users where ID equals 1. So it's going to go and look in the database for the user ID 1, get it, and return it. Now the where, that's the conditional statement. Now if you put in that where, so you were able to influence this ID, okay? And let's assume this ID is a web application parameter, and you add or 1 equals 1, all the records in the database are going to be returned. Okay? Because or 1 equals 1 is always true. If you go and you put in equals 1 and 2 equals 1, it's always going to be false, so nothing will be returned. So this one will return one record, this one will return all the records, and this one will return nothing. You know there's SQL injection, right? The problem with blind SQL injection in tautology testing, though, especially if you use tools like Zap or Burp or AppScan, is false positives. Because sometimes the server doesn't respond in time, or there's some other type of errors that cause differences in the responses. So just because you found an unexpected behavior doesn't mean it has to be constantly reproducible. The ET maneuver, okay, so the ET maneuver, what does ET do? Calls home, right? So especially in the case of OS injection, you could add commands that call home. So for example, this is your user input. You can ping a server that you control. Okay, so the application might not return anything to you, completely blind. You don't even know if anything happened, right? But if you get a ping back, that's how you know. Okay, so you know that, and another way to do it is use a curl command. That's going to execute an HTTP request to your server. So you can have a server in AWS and look at the logs, and if the request comes in, then you know it's vulnerable. For those who have Burp and have the pro version of Burp, the Burp collaborator actually gives you a server, a host name. So if you use the Burp collaborator, it will just give you a dynamic URL like this. And if your command injection succeeds, you're going to see there, even if the server tried to resolve DNS, right? Even if there was a firewall, maybe it didn't allow the ICMP request go out or the HTTP request go out, but it was a DNS resolution, then it will tell you, right? So I find that very useful. You don't even need a server of your own, right? Glassbox is another excellent way to find injection. A lot of us are doing QA, developers, testers. If you do have access to the application, you want to make sure there's no injection in it. One thing you could do is go and look for quotes and tail the application logs. If you see syntax errors in the log, so you could do a grep through the log to find the syntax error, SQL compile parser errors, SQL related stuff, command, operating system command stuff, then you know something is fishy, right? And that's an excellent way of finding it. Now, I talked a lot about the quotes, but there's other symbols. For LDAP injection, you have the brackets, the pipe, and the ampersand. So those are used for logical operation, and the brackets are used to group statements. NoSQL injection, you have the where close, then you have JavaScript type of symbols. You can also use semicolon and equal in SQL injection if quotes are not being used, like in the case of the ID parameter I was showing you earlier. If you put a semicolon, that causes a problem, breaks the statement. For command injection, well, in Linux is, well, you name it. Semicolon, ampersand, pipe, $. Which one of these work in Windows? Can anyone tell me? It's the ampersand. So the ampersand is the one that glues command injection in the Windows command line. Okay, so if you use manual testing, that's one way to look for it. So you will exercise the application and put in symbols. But automated tools are more efficient. They can be built into your CI/CD pipeline. And so they can also do numerous payloads that you don't know, right? In order to find vulnerabilities. OWASP is the automated tool maintained by OWASP, and it's free. Shameless plug. And then you have other dynamic analysis tools that, Burp is one of them, and you have AppScan, WebInspect, go ahead. Then you have static analysis tool. So the static analysis tool analyzes the code graph in the application and try to determine insecure coding. So static analysis tools are looking at your code and looking for missing best practices. And I don't know of any free ones that I can recommend. So to sum it all up, unenclosed quotes break the command query, allowing you to find errors. Look for behavior changes, even if an error doesn't show up. Try to go home, look for errors in logs if you have access to the logs, and use automated tools such as OWASP. How to exploit injection. I know you guys not interested in this at all, but it's still good to know, because if you see any of this in your application logs, it means that somebody's trying to hack you. Okay, so the magic credentials. So these are usernames or passwords that get you logged into the administrator account of an application or into other user account. So what's happening here? The first one, admin quote dash dash. The dash dash is a comment in SQL. So what that does is says, log me in as admin and ignore the rest of the statement. Because you can imagine the rest of the statement is going to be where password equals this hash or something, right? So you're commenting out, so it's actually where username equals admin and here was password equals this hash. Then this one, it works in similar way, but if you can't insert these dashes, right? Then you just insert this or 1 equals 1 in the statement. And then if you don't know the name of the admin, you can just try quote or 1 equals 1. The union keyword. So in the case of SQL injection, if you don't have access to the sensitive tables, you want to try to get access to a sensitive table. Let's say you have access to the articles of a blog, but you want to get information from the users table. You use the union keyword. So let's say the vulnerable SQL statement is select article ID blah 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 from articles where user ID equals to 15125 to get the user's articles. And you want to get the usernames and passwords. So what you do, you can use the union, insert the union here, to append the output from the users table to the original table. And you can use 1 to fill in fields that don't match, because sometimes SQL statements you'll have this selects 3 fields, this selects 2 fields. So you can add 1 or multiple ones to fill in the missing fields. So then the output looks just like in the screenshot there. What else? Deploy malware. The Heartland breach, they use SQL injection to deploy malware. And so you think, how did they do that? Well, the one at the bottom here, there is a stored procedure in MS SQL Server called XPCMD shell. If that's enabled, you can execute commands. So that was like a hybrid SQL injection, command injection type of attack. So you say exec XP command shell, and then you just put the rest in here. Or if you just have command injection, obviously you can execute any command. So download your malware, put in your reverse shell, you pwn the server, right? So to sum it all up, injection can be exploited in powerful ways. You can break authentication, you can exfiltrate data, you can install reverse shells and malware, and injection usually is a maximum impact. So if you're looking at the vulnerability severity, injection is the type of severity of a vulnerability that has CSS 10. So the maximum vulnerability you can get. Okay, so maximum impact on confidentiality, integrity, and availability of the system. So I thought I should give you a little bit of a demo. We're going to start with command injection. So this website here allows me to log in and change the this application settings to download from a different update server. Right, so you have update the settings the server settings below, and you have the update server right here, okay? And when I hit update, what's happening? It's going to do a connectivity test. You see this type of functionality in routers all the time. Now, surprise, routers, one of the main applications vulnerable to command injection. And so you see that it's trying to do a ping to my input, insecure ink. Now I go, what do we say about searching for injection? Quotes. So I'm going to go put in a quote. So when I put in a quote, I see the error, right? Unexpected EOF. I mean, it's pretty clear it's opportunities for injection here, but just to prove the point. If I end the quote, then it looks just like the same like before. So you end up having insecure ink. Single quote causes an error, double quote doesn't cause any error. Okay, so I established there's injection, now I can take advantage of it and execute any command I want. So one of the things that hackers do, now this is the password file. You used to have all the passwords, all the users and the passwords. It has since changed, now there's a shadow file. But if your application executes with root credentials, which I've seen a lot of applications do for legitimate reasons or not, then you can get that shadow file as well. And then you can use a password cracker and get into the root account or any other account that has access to the system. You can get keys and all kind of things. Okay, so, but I'm just going to show you getting the password file. Right, so I added again semicolon, so that ends the first command, and then cat etc password outputs the contents of the password file. And now I'm going to show you how we can find this injection with ZAP. So I'm sending the HTTP request to ZAP. You can see in the corner there, my Foxy proxy extension is sending all the traffic from the browser through ZAP. And then if I look here, I see the post request came in, and that's how it looks. This is how the HTTP traffic looks like. And now I'm just going to attack this request. So like I said, automated tool, very powerful. A lot of requests happening there. You couldn't do them so fast, right? Let's see if ZAP found anything. Sure thing it did. There's a remote OS command injection right here. And bonus, a cross-site scripting. So not only found command injection, what an insecure application. And we can see that it did exactly what I did earlier when it tried that cat etc password, and it found the root coming in the output, and it decided that is command injection. Now the other demo I wanted to show you is SQL injection. So here we have a login page, and I'm going to try to log in using the magic credentials. So we're putting one quote, we get an error. And we can see right here, select start from users where user equals admin and password. We put two quotes, no error. So there's an SQL injection. So now we're going to try to make that SQL query work for us and return true all the time. Okay, that didn't work. So select star from users where user equals admin or 1 equals 1 equals quote 1 2 quotes and password equals quote quote. So I have to get rid of one quote to make it work. So just like that. Admin or 1 equals 1. And I logged in. And then I'm going to use burp to find this injection. Okay? So I'm going to change my proxy here. You can see I have lots of proxies. Change it to burp. And send this request through burp. It has arrived. And just like I did with Zap, they operate the same concept. It's going to do an active scan. And you can see it found an SQL injection already. So notice that it's putting a question mark because it's not sure. Okay? It's not sure because it found the injection not because of the error, but because it compared the responses. So this one is a better example. This is where it went and it did pretty much what I did, right? It did an OR, 9718 equals 9718. And then it compared the responses and you can see the difference. When it did the tautology attack, it logged in. And then this is a false statement. 5225 equals 5223. It didn't log in. So this is the login page. So that's how I figure out there's SQL injection. Okay, so that concludes the demo. So how do we defend against injection? Probably going to say no quotes, right? Don't allow any quotes. Make Dr. Evil sad. Yes, quotes are not needed. Majority of application parameters are not intended to contain quotes. Okay, so if you look at your HTTP request, we have there a cookie, which is a hexadecimal number. Then you have a host name, which is alphanumeric plus dots dash, not quote. So a lot of the parameters there, it's clear they don't need quotes. Parameters going into database queries, such as an ID from a user, which is numeric, true, false, ascending, descending. They even have a small character set, and they're ASCII characters. So I want to talk a little bit about whitelisting versus blacklisting. So the people feel the need to just block. When they see a payload, they see a code causing an error, they're like, okay, we have to block this. We have to look in the input and see if there's any quotes. If there's quotes, we're just going to reject the command. But that's the wrong way of thinking about it, because that's called blacklisting. And blacklisting can be bypassed. And it can be bypassed in various ways. Encoding attacks, type of quotes that you don't know about. Also injection without quotes. Like if you're blocking just for quotes, well, there's injection without quotes. So, does any of you remember how many times they tried to fix shell shock? Because they kept coming up with payloads that were bypassing the blacklisting. So blacklisting is not as effective. So rather than saying no quotes, say only letters or numbers. That's a better way. Have a positive approach to it. Okay, so a lot of people are going to say, oh, whitelisting. If I'm just going to say only letters or numbers, how about international characters? You know, how about multi-language support? No problem with that. You can do whitelisting and do Unicode validation. So in Java, character is letter, it's a Unicode validation. So that character is true. Okay, that's a Chinese characters for person. Character is letter, that's a French accent. Again, it's true. So you can do Unicode validation, you can do whitelisting, you're not going to break multi-language support. And you can have a validator like this. It takes a string and an array of exceptions, and then it iterates through the characters of the string. It checks each character. If it's letter, it's okay. If it's digit, it's okay. If it's one of the exceptions, it's okay. And if it didn't meet all the criteria, then it's false. Okay, so it's very simple. And then if you pass all the criteria, right, it's true. And that function, that little function, is multi-purpose. It can be applied to all kind of inputs. For example, Boolean values in your parameters, ascending, descending, numeric, alphanumeric, hexadecimal, things like session identifiers, host names, email addresses, all kind of things. And then, once you implement this function, you can implement the proper type of error to show to an injection attack, which is, a pen tester or an attacker never wants to see this kind of error, which says bad request, invalid input must be alphanumeric. Okay, that's the error you want to show. And the more you put input validation, the more alphanumeric characters validation you have, that's going to decrease the number of vulnerabilities of applications. So the amount of vulnerabilities statistically input vectors away. And input whitelisting prevents all kind of attacks. Okay, so maybe your input didn't go in a command, but it went into a page. Well, guess what? Input whitelisting prevents against cross-site scripting because they're not going to be able to put symbols and other things in there. It prevents against path traversal because they're not going to put // open redirects, deserialization, all kind of things.
What if my name has a code in it?
Oh, but I have an answer for you right here. Yes. He says, what if my name has a code in it? What?
He's just confirmed, right?
He's a prop. Yes. What about the Irish? Right? What about them? They have like O'Brien, name like O'Brien.
That's discrimination.
Exactly. How about don't? How about putting things in quotes in an article? What do you do about those things? So input whitelisting definitely reduces the attack surface. So you have to use it on things that you know for sure are going to be alphanumeric, but it cannot prevent all attacks. So how do you prevent those? Well, we replace concatenation with parameterized commands. Okay? So you'll have, what's going to happen is the SQL driver is going to send the data this way. It's going to send the command, which is going to be a constant, and then it's going to send parameters to it, which are your inputs. And the command interpreter will not concatenate anything. It will execute this command with these values. Quotes will not break the command. And we have parameterized commands for OS commands and SQL and in all kind of areas. So let's see if you guys are still with me. What kind of defense is this? Input. Sorry?
Parameterized.
It is a parameterized command. That's right. So the Java prepare statement is a type of parameterized command. You can see the question marks there. Your query is constant, and then the Java sets the values of parameters. How about here? It's a parameters passed into a command, so it is a parameterized command. How about here? That's right. You shouldn't answer all the questions. Okay, so this is input validation, correct, but is it only input validation? No, it's also parameterized command, okay? So here we had to use input validation and a parameterized command because this application wants to be platform independent. So it checks the operating system, and based on the operating system, it passes the command interpreter, right? It says either CMD or shell. If you do that, it doesn't matter if you concatenate or not, you have injection. Because this is going to be passed, all this input is just going to be passed to the interpreter, and the interpreter will do whatever with it, okay? So you need to validate the input. An even better way to prevent SQL injection are ORM frameworks. So ORM, it's not worm, it stands for Object Relational Mapping. And so what they do is they take a Java object or other language object. In Java they're POJOs, plain old Java objects. They have no logic into it other than storing information. And they'll just be passed into converted under the covers into a command. And it's a parameterized command usually. Okay, so developers don't even have to operate with statements and SQL queries. If you didn't know, we also have another project which is a security library, the Enterprise Security API. And this is an open source library that contains security control. The nice part about this, you're going to say, oh, I'm just going to write my little own function and it's much easier. The nice part about this is that it has been written and tested by application security experts, and then it's also recognized by static analysis tools. So you don't get false positive when Fortify or AppScan scan your code because they know it's an ASAPI API call, so you don't have to define your input validators. Okay? Because a lot of times static analysis tools that look at your code, they don't understand that that function validates your code, validates the input. Also, using automated tools. Okay, so maybe you don't have a way to deploy a fix to a vulnerability. Intrusion detection and prevention tools have automated blacklisting rules, which can be bypassed. But the thing about these tools is when an attacker is trying to break into your application, they'll try all kind of payloads. If they are able to bypass the IDS or IPS, they can get in. But you're going to get alerted because one of their payloads will trigger the IPS. Okay, so it's very important, the monitoring aspect of them. Also, runtime analysis tools instrument the application and can detect the exploit and block it. So there's tools that are running in your application as Java agents and look at the input coming in and they see that there's a SQL statement being executed and things don't look normal, so they can reject that operation. So they're kind of like your developer, automated developer fixing the application while it's running. So to sum it all up, input whitelisting reduces the attack surface and prevents many attack types. So it's golden, you're going to keep hearing about it. Parameterized commands handle situations where hazardous characters are needed. I would use both, input whitelisting and parameterized statement, just to be sure. ORM frameworks prevent mistakes. OWASP API provides a set of handy security functions, and automated tools, IDS, IPS, Web Application Firewall, and RAS can alert and prevent some of the attacks, but they are not a replacement for secure coding. Okay, so test all your knowledge. Everything you learned in today's session by going to this URL. We're going to tweet about it. There's a version of the Secure Coding Dojo, and these challenges that I showed you in the demo running there. You have to pass the SQL injection challenge and enter the play code in quote space or quote one quote equals one quote quote or injection. So it's pretty much an interjection. I know. I have dad jokes in the program tonight. And you can get a participation badge via badger.io, and that you can tweet, link, put it on your LinkedIn, etc., just to show that you participated in the session and that you got the concept of injection.